Assalamualaikum and a very good afternoon to my panel of examiner and my fellow presenter. I 21703115 Muhammad Khalifatullah bin Abdullah will be presenting the project entitled Design and Implementation of Haptic Feedback Controller for Robotic Arm, in specific 2 degree of freedom robotic hand. This project is being supervised by Associate Professor, Technologist, Geospecialist Dr. Syed Muhammad Fairuz bin Syed Muhammad Dadin and Captain Zahri bin Abdul Rashid. So moving on to the scope of this presentation. The first is introduction, methodology, and then is analysis and some demonstration, and then end with conclusion. The first element is the introduction. So the background of this project is in chemical, biological, radiological, nuclear and explosive or CBRNE accidents require sample collecting manually for any further action to be taken. The procedure requires an extensive precaution and a very time consuming, as it involves equipping protective clothing, sample collecting and decontaminating. Robot as intermediaries can shorten the procedure to procure the sample safely and securely. And applying haptic feedback system will give the user sensation of touch, pressure and weight as operating the robotic arm. Moving on to the problem statement. First is designing robotic hand with haptic control system for the operator to be able to receive feedback from the robot. Servo motor issue on implementing the haptic feedback, sensing the sample and determine amount of force applied, and sensing perturbation when the robot is obstructed. So the objective is, the first one is to explore technique involved in haptic feedback system. Second is to implement the haptic feedback technique in robotic hand. Lastly is to assess the effectiveness and evaluate the performance of dexterity capability of the haptic model and its responses. Scope of this project. The haptic system will use force feedback through the built-in potentiometer in shelf-ready servo motor as sensor. The design and control of the haptic system will implement bilateral method on the robotic hand. The performance of the haptic system will be evaluated through potentiometer data and dexterity capability. The next element is methodology. So this is the project flow and the process. The project is divided into 3 phases. The first one is servo motor movement. The second one is hardware prototype, and lastly test and evaluation. So this is servo motor movement. It is hacking servo motor. The right side depicts the internal servo motor which being hacked. The internal potentiometer, the yellow one, is connected via copper wire to send signal to Arduino. The left side show how the hacked servo motor will be connected to Arduino. So the internal potentiometer will connect to the analog pin, while the servo motor will connect externally. This is the comparison of the system of open loop haptic system and closed loop haptic system. So the difference between both systems is at the servo 0, which is one is connected to motor driver and one is connected directly to the Arduino. So the CAD design of a robotic hand and operator. 4 finger, this picture, the 4 finger is to be represent the first degree of freedom, while thumb represent the second degree of freedom. Each limit is each angle is the limit set on the robotic hand to limit the robot movement to grasping gesture. And for the operator, 2 types of servo arm mount is designed. The first one is joint type, and the second one is the arc type. The arc type is created to increase the performance of joint type, which will be discussed later on. Next is haptic hardware. The circuit is based on closed loop system of haptic servo. So the servo 0 and servo 2 is for robotic hand. Servo 1 and servo 3 is for the operator. Why closed loop system is chosen will be discussed later. Haptic hardware setup. So this is the configuration. The left side is the joint type and the right side is the arc type. As you can see the connection on operator's glove. So the black thing is glove. So the servo used is servo 1 and servo 3. For robot is servo 0 and servo 2. So this is a grasping test equipment. So the test will focus on servo jittering as force sensitivity is transferred to operator and haptic response on perturbation effect. Sponge has characteristic of light and soft, which is compressible. An empty container is light and soft, which has very high tendency to indent, and the solid container is heavy and hard. So result and analysis. So this is the comparison of the system, open loop and closed loop. So the response time for open loop is longer than closed loop. The closed loop system responds as fast as the input is given, while in open loop there's delay in information process of the operation system. The blue line represent operator, while the red line represent the robot. So this is as perturbation effect. So the response time for open loop is around from here to here around 770 milliseconds, and the closed loop is from here to here around 370 milliseconds, which is show as the perturbation occur. So the haptic response, the time taken for the haptic response to operator to move towards the robot angle rotation. Same is the comparison between joint type and arc type haptic reading. So when grasping a sponge, so the blue line P0 and orange line P2 represent the robot, while red line P1 and purple line P3 represent the operator. Joint type servo arm provide less sensitivity for force measurement towards compressible sample sponge, and more perturbation occur as less force feedback is received by operator. Perturbation occur as it is less force sensitive. Comparison of hardware haptic reading on haptic container again by joint type and arc type. So same as graph before, blue line and orange line, P0, P1, P0, P2 is robot, P1 and P3 is the operator. And joint type occur perturbation when grasping an empty container, then the jittering begin as the container indents. Hence, this is the jittering effect at the servo. The arc type face the jittering effect first, and then manage to stabilize the effect. So the force sensitivity fluctuate as the sample is indent. Comparison of hardware haptic reading of solid container. So the effect of solid container on both type does not show much difference. However, more on similarities, as no indentation or compressible sample. It is hard and solid. So next is demonstration. So as the operator grasping the robotic hand imitate the grasping gesture, the data fluctuate as the robotic hand grasp the sponge. Same when the operator grasp, the robot grasp. So there's indentation occur at the empty container. See at the location. So hence the jittering effect. Next is on solid. So this data show more stable output as it is solid and not compressible. Hence no jittering effect. So the analysis of the results is the matching capability of closed loop system surpass open loop system because open loop require delay to initiate. The haptic response of closed system when perturbation occur is 400 milliseconds faster compared to open loop system. And lastly, arc type servo arm perform better result than joint type servo arm in force sensitivity and response on perturbation effect towards compressible sample. As in conclusion, the capability of servo motor function as haptic feedback sensor and actuator is feasible within its limitation. Haptic feedback using closed loop system and for optimum haptic feedback response controller, the hardware designed for operator and robotic hand concern on the servo threshold limit. The implementation is succeed when the 2 degree of freedom robotic hand capable to grasp a sample and providing force feedback to the operator. That's the end of presentation. This is the poster layout. All the information in the poster is the same as the slide. Not much is differ except for including the reference. That is all I have to say. Thank you for listening, and I'll be happy to answer any question that you may have. Thank you.
Thank you. Okay, may I go first? First question.
Yes, sir.
Okay. First of all, I just want to clarify what is the analog value in your graph. What is it? Is it the pressure? Is it the voltage or what?
It is the potentiometer reading, sir. So the reading, yes sir,
Okay,
analog
potential
reading
meter reading.
from 0 to 1023 sir. That's
And
analog.
it's representing?
It representing the rotation at the servo motor. So
The rotation.
yes sir, the
Representing
potentiometer
the
is,
rotation. Okay.
yes sir.
Okay, so you did not map it to any value like pressure or anything. You take it as a rotational value. Okay.
Yes sir. Yes sir.
Okay, so we see that there is perturbation. Physically, it happened because, especially when you grasp a soft object, right? For example,
Yes.
just now. Okay.
Yes. When the operator does not receive the feedback properly by the robot.
Okay. Why is that so, and how do you think to overcome that situation?
In my opinion, because the selection of my sensor is the potentiometer, but the potentiometer only have 3.5 kilogram per centimeter of torque. So it doesn't supply enough torque value for the operator to receive proper feedback, proper force feedback. Hence, the operator can give more pressure, although the robot said enough.
Okay.
Yes,
You're
sir.
talking about the sensitivity resolution of the potentiometer, right?
Yes, sir.
Okay. Okay, thank you. Okay, anyone else want to ask question?
Hello.
Hello, ma'am.
Okay. Did you get the data for the maximum or minimum pressure?
Potentiometer, yes. I've included in my FYP1 presentation, but I doesn't include in this presentation.
Okay.
Because yes, yes, ma'am.
Okay. It's okay. It's just that the concern is that the pressure. Okay, how much pressure will the threshold of the pressure of the grasping, so that it will not damaging the
servo.
yeah. Okay, so that's my concern. So do you think that it is a mild concern, or is it, you
I
have
guess it's quite significant, ma'am. If for small servo motor, because the torque is small, as the operator can give more feedback, will harm the robot servo. However, if the servo can be changes, so I think that I think it is more robust for perturbation to occur.
okay? So you think can make improvement on that?
Yes, yes, ma'am.
Okay, okay, that's all from me. Thank you.
Mr. Key, do you have any question?
No, at the moment.
Okay, so thank you for spending time with us.